Okay, so I'll comment on future Mandela effects and how they come about. Obviously, you need to have seen my video on the game of life to understand that I believe that the Mandela effect, like all other ontological effects, yeah, it's an ontological effect. It's not an ontic one. It's not something that you can physically touch. It's something that can affect you without you being able to see or touch it. So with all ontological effects, you have to consider a paranormal component, a paranoia component, and a conspiratory component. So PCP. There you go. Yes. No, let me call that CPP because obviously we don't want people. Anyway, so that's CPP. Conspiracy, paranoia, paranormal. So now we're dealing with the conspiracy aspect of the Mandela effect. This is where people conspire to bring about a reality. Yeah, and there's a lot of secret societies that do that. And a famous scientist earlier this year pointed out that he noticed that scientific research was being tampered with by people and organizations external to the scientific community. And basically they have an agenda, a belief, and they want to invest in only projects that promote their agenda and beliefs. But that's how it works. Yeah, we're in this reality because that's how it works. That's how it's always worked. And basically, if you can argue your point, anything is true out there as long as you can tell us why it is. Yeah, as long as you can give your reasons to why it is, it's true. Yeah, everything is valid. Even quantum physics tells you that everything is true until you see for yourself. So I have a feeling that somebody once, I don't know how long ago they came up with this concept. Oops, what am I doing? I don't know how long ago they came up with this concept, but basically, let me just change this. Hold on 1 second. That looks like a dick. Let me just change this. I was just dreaming. But yes, they do call it that actually. Why am I changing it? They do tell you that 1 divided into 0 is infinity, don't they? Yeah. So basically, we must have found a situation in history where people started to say to themselves that what happens when you divide a number into 0 stack. So if you have a stack of 10 things, if you have a stack of 6 things and you divide it into stacks of nothing, yeah, what do you have there? And somebody must have said infinity. They came up with another imaginary number called infinity. Why do you come up with an imaginary number all the time? It's a cop out. If you don't know, just say I don't know. Don't come up. Anyway, so he must have been a scientist who didn't want to lose face and then used his influence to drive the idea that any number divided into 0 is infinity. And this is the reality we're living in right now. But obviously, that scientist is gone, all copyrights are gone. Anyway, so you have this video I prepared just to give you a little background. I'll tell you, like, when you come across, if you're chasing someone towards a roundabout and they're 2 minutes ahead of you, by the time you get there, you have 3 different directions where they could have gone. So you could ask your mates, go one direction, go another direction, and the other one, go another direction. I'll stay here just in case it comes back through. So you need to cover all directions before you actually become confident that you're doing enough to find a solution to a problem. So when the scientist said that external influences on science are harmful to science, that is true. But then again, these are the people that create. That's how they create the reality that we're living in terms of the Mandela effect. That's how these Mandela effects come about. It's a struggle for influence. You have one philosophical school that's influential, another one's influential, and they resort to those kind of tactics where they push through ideas which lead them, which will make us follow them into a direction which they've already come up with. A solution which they've already come up with. So there's gonna be those power struggles. And another comment I wanted to say now: if you have what I call the CERN was the European Research Center, yeah, CERN. So if you look at the parallel universe theory that we have, yeah, if the people in CERN in other universes, they are also trying to do the same thing that CERN is doing in this universe, but I heard that CERN said that they actually destroyed another parallel universe. Now, if you try to destroy a parallel universe where there is a CERN that's trying to do what you're doing, they're not going to want to be destroyed. Yeah, and the same thing might happen to us. Another CERN from a different universe might be trying to destroy our different. It sounds like Jet Li's movie, The One. So you have all these different CERNs, trying to fight each other to stop each other from being destroyed. That's why I call it the CERN Wars. It's just a fictitious parody, if you like, yeah, or anecdote that I wanted to put into this video. Anyway, back to the matter at hand. Yeah, so I call it hand division, right? Just listen. So this is what devalues the certificates we get at university. When you reach a point where somebody tells you, right, for you to get from A to B, or to get your certificate, you need to agree with what this person has done. And you know in your heart as a scientist that what they have done is just lying. It's lies, yeah? But because they have influence, you're not getting anywhere until you go on board with what they're saying and then design your research to follow that direction, yeah? So you get disgusted as a scientist when you see that. And this is what I'm saying. Some of those certificates ain't worth the value of the paper that they're written on. But anyway, let's get into the demonstration. Hand. Yeah. How are you? Yeah. You're looking fit. Yeah. Right. So I want you to go and count that stack. Yeah. There's one stack there. Go and count how many coins are in that. Yeah. Okay. Good hand. Yeah. You're already arranging them so that they can be counted. Yeah. Six coins. Thank you very much, hand. Now stack them up again. So there's 6 coins there. Okay, now hand. I want you to look at that stack there. Yeah. I want you to divide it into stacks of 2. Yeah. Yeah. Three. Yeah. 3 stacks of 2. Yeah. Excellent. Right. So now stack them up again into one stack that you found there. 1 stack of 6. Yeah. Now I want you to divide that stack of 6 into stacks of nothing. Yeah, that divided into stacks of nothing. Yeah, there. Okay. Come back. Right, so how many stacks of nothing do you see there? Yeah. Hey, that's odd. You see 1 stack of nothing. 1 nothing. There will be. All right, I see your point. There's nothing there. If nothing exists, once, then it's nothing. But if nothing doesn't occur twice. Nothing is actually 1. There's 1 nothing. You've never heard of 2 nothings. There's always 1 nothing. Yeah. So there is 1 stack of nothing. What else do you see there? one stack of 6.
You always forget
so
about
one
the
stack
stack
of 6
that you see there.
and one nothing.
Pragmatic
One stack of
mathematics.
nothing.
That's what you
Okay,
see.
thank you very much, Han. That will be it. Thank you.
You can't see nothing because it's nothing. But that's what you see. When you divide 6 into nothing, what do you see there? You see one stack of 6. You can say one stack of nothing because there's nothing. Nothing is always there. If you look at it that way. If you look at it that way, then nothing is 1. There's one universe. One creator. Yeah. And you in your mind, you're one imagination. Your imagination is nothing in physical reality. You can't make nothing manifest from your mind and have a physical presence. At least, if you could do that, then you'd be gone. You can't think of something like, look, I'm thinking of an apple, now I want it to appear here. It's not going to appear there. Yeah, what's in your head will always have a value of 0 in the external world, in the created world. Now, let's go through this quick and simple. Pragmatic mathematics, dividing by 0. Let's start off with a normal example. 6 divided into 3. Do that on your calculator. 6 divided into 3 is equal to 2. Another way of putting that is 2 powers. You know when I was stacking them up here? 2 stacks. Yeah, 2 stacks of 3. 6 divided into 3 is 2. Which normally said verbally is 2 powers of 3. If 6 is called n and 3 is called m and 2 is called p, this can be written as n divided into m equals p powers of m. This is that 3 there. If 6 divided into 3 is 2, then if you multiply both sides by 3, 6 divided into 3 times 3 equals 2 times 3, you get 6 here and you get 6 here. 2 times 3 is 6. 6 divided into 3 times 3 is 6. You can do that on your calculator and do that on your calculator and you end up with 6. Which you can write. You can write this 6 equals that as this. 6n equals m added up the number of times n added up 2 times. So from 1 to p, 1 to 2 in this instance. That's m once, that's 3. Yeah, m twice, 2, that's 6. 6 equals, yeah, right? But in classical mathematics, anything divided into 0 is infinity. Why? You invented another magical number there. Those are two magical numbers that we have in science here. Yeah, root minus 1, which is the I, imaginary number, and infinity. Why? So anyway, I proved to you in my earlier discussion that I is equal to 0. Now I'll show you what infinity equals. Now 6 divided into 0 will give you 0 stacks of 0. Yeah, what you see there is 0 stacks of 0, but you also see 1 stack intact. One stack of 6. So my pragmatic mathematics, I say that 6 divided into 0 is not infinity. 6 divided into 0 is 1. 1 pile of 6 is what you see there. What do you see there? Do you see infinity? No, what do you see there? You told me, what do you see there? Right? You see 1 pile of 6. I told you, things become theory. If I can't tell you why I believe that, yeah, I'm sure you can agree. Yeah, if I divide, I showed you with hand, we try to divide that into piles of nothing. We see no piles of nothing there, but we also see 1 pile of 6. So 1 pile of 6 and no piles of nothing. Also, to point out that nothing divided into nothing is also 1. This is a universal law. Anything divided into 0, yeah, is equal to 1. In fact, let me put that there. N divided into 0
equals 1. Yeah. I'll add this up as I go along. Yeah. Right. I'll put that there. Okay. Right. I've just proven it to you pragmatically. If somebody tried that con trick on you to make you believe that if you divide a number by 0, you get infinity. What about your 6 coins? Every penny counts, you know. So what I'm saying is, reasoning wise, when you divide a number by 0, the 0 becomes the number that is being divided. Yeah. When you divide a number by 0, the number being divided becomes 0. Now, going by this one, 6 divided to 0 equals 1. That's what I'm saying. So either that equals 6, because 6 divided to 6 equals 1, or that equals 0, because 0 divided by 0 equals 1, which is also my theory here. But otherwise, in your classical mathematics, yeah, you also have 0 divided to 0 equals 0. Yeah, in your mathematics. Yeah. Okay. And also that. Yeah. Okay. Right. So, but in my mathematics, either that becomes 0 or that becomes 6. Yeah. Both cases, 0 equals n and n equals 0, saying the same thing. Now let's look at where m, the number that you're dividing it into, yeah, remember m from here, where m is less than 1, is less than 0, sorry, less than 0. Let's say m is minus 3. You know, if you do that in your calculator, 6 divided into minus 3 is minus 2. Yeah, or it's the same as 6 divided to minus 3 is minus 2 powers of minus 3. Minus 2 powers of minus 3. A minus value is 0. I told you that already in my previous discussion. Yeah. If you can't see minus 2 stacks of minus 2. Stacks of minus 2 will always look like 0. Minus 2 itself looks like 0. Yeah. I proved that to you with subtraction. Yeah. So a minus number, any number taken away from 0 is 0. Yeah. So therefore, that minus 3 is 0. And as we know from here, yeah, if that minus 3 is 0, as we know from here, yeah, 6 divided into 0 equals 1, according to my pragmatic mathematics. Yeah. So in your world, 6 divided into minus 3 equals 2, or 2 powers of minus 3, which is bullshit. You can't see minus 3. But in my world, 6 divided into minus 3 is 1. Yeah. Or 6 divided into minus 3 will give you, that will still be there. All your minusing crap will still be there, which can't be seen. That's the only thing that will be seen. When you try to do that, all you see is one pile of 6 and no piles of minus 3. Where are the piles of minus 3? But there's one pile of 6. So that will be one pile of 6 and no piles of minus 3. What remains, what you can see, is one pile. Yeah? I rest my case.